Pressure testing gas lines for leaks should always include a careful inspection of the flare connection surface and nut, because a leaking flare after multiple attempts usually points to damaged or improperly formed flare components. When a flare connection keeps leaking after several attempts, first remove the fitting and examine the flare surface under good light or with a magnifier. Look for scratches, nicks, gouges, or cold flow ridges on both the male flare and the mating cone inside the nut, because even hairline damage will prevent a metal-to-metal seal. Second, measure the flare angle and flare width with a flare gauge or a vernier caliper. Standard fittings use a 45-degree flare for most gas work. Any deviation or an oval shape means the tubing must be repaired or replaced. Do not try to force a damaged flare to seal. Third, inspect the nut threads and the cone inside the nut for deformation or extrusion. A nut with a flattened cone will not compress the flare evenly and should be replaced rather than chased. Fourth, check the tubing end for a clean 90-degree cut and proper deburring. A jagged or angled cut creates gaps and stresses the flare when tightened. Fifth, verify the flare tool setup. The clamp jaws must center the tubing and the flaring cone must be free of burrs and lubricated per tool manufacturer guidance to produce a uniform flare. Sixth, if you suspect work hardening or cracked tubing at the flare, cut back past the suspect area and refair a new section. Never attempt to reuse a work hardened or microcracked flare. Seventh, for stainless steel and copper lines, consider using a flare backed by a thin ferrule or sleeve only when specified. Otherwise, a sleeve can prevent proper seating. Eighth, after assembly, perform a pressure test with soap solution or an approved electronic leak detector at the joint while holding the system at test pressure for the required dwell time. If bubbles or detector alarms persist, disassemble and repeat the inspection steps rather than over-tightening, which only damages components further. One of the biggest mistakes is assuming a tight nut equals a good seal. Over-tightening often causes flare deformation and thread damage. Fix this by replacing the damaged components and using a torque wrench to the manufacturer's specified torque. One of the next common errors is reusing a visibly scored or oval flare, which leads to persistent gas leak problems and failed pressure tests. The corrective action is to cut back the tubing and produce a fresh, concentric flare with a properly maintained flaring tool. One of the third frequent issues is contamination or burrs on the flare surfaces that prevent seating and create small leak paths. Remedy this by thoroughly deburring, cleaning with a lint-free cloth and solvent, and reassembling with new nuts if the cone surfaces show any damage. BigHomeProjects.com lists vetted local contractors and specialists for gas piping and leak testing, helping homeowners quickly find experienced technicians who follow correct flare inspection and pressure testing practices. The directory also helps contractors get work by connecting them with local leads and homeowner reviews, so pros who handle persistent flare leaks can grow their business.